Zeal Education Society, redefining excellence.
Hello students, in a previous lecture of the AC fundamentals, we have solved few numericals based on the RMS value, average value, instantaneous values, the form factor, peak factor, and so on. Now in this lecture, we are going to learn what is phase, phase difference, in phase quantities, phase lag, and phase lead. So to understand the phase, let us consider the current equation small I equal to I max sine omega t. Now its graphical representation, its waveform will be, so this is the waveform. This is the time period t. Here it is 0, here it is current. Now say this is the point here it is origin. And note that this omega t is nothing but theta. Now the phase means a fraction of time period. Phase, the fraction of time period measured from origin or reference. It may be angle, it may be in terms of angle, in radian or degree. For example, this is point A, this is point B. So at point A, the phase is omega t equal to t by 4, and at point B, omega t equal to t by 8, or here will be pi by 4 equal to 45 degree. And for this, it will be omega t equal to pi by 2 equal to 90 degree electrical. So the phase may be from 0 to 360 degree. The phase may be from 0 to 360 degree. It is okay. This can be applied for the voltage waveform also. So at this point, omega t, and here omega t equal to t by 4. Here it is equal to t by 8. So this is about the phase. Now let us see the in phase. What is in phase? Let us consider the two similar quantities. Two similar quantities, say the voltages. So E1 equal to say EM1 sine omega t and E2 equal to EM2 sine omega t. Now both these waveforms indicates that their magnitudes are different, but they achieve their maximum and minimum values at the same time. This is E1. The electrical quantities may be a voltage, two voltages, or voltage and currents are said to be in phase when they achieve their maximum and minimum values at the same time. Now this can also be expressed by means of voltage and current. This can also be expressed by means of voltage and current. Let us consider, see, this is the voltage. See, this is E equal to E max sine omega t. And I equal to I max sine omega t. Here also, if you observe carefully, both the quantities, voltage and current, achieve their minimum, maximum, minimum and maximum values at the same time, and therefore they are said to be in the same phase. Now let us see the phase difference. Now for the better understanding, let us see the coils, three coils or two coils. Say this is x-axis positive, this is minus x, say this is y, and let us consider the three coils. Say its angle from the reference, x is the reference, it is omega t. This angle from the reference is omega t, and say the second coil now its angle from this is say alpha, and say the okay. Now say this both the coils are rotating in counterclockwise direction. Both the coils have same number of turns, same size, and placed in uniform magnetic field and rotating in counterclockwise direction at the same speed. And therefore, EMF induced in say coil A, EMF induced in coil A is say E1 equal to E max sin omega t. Then EMF induced in E2 equal to E max sin omega t plus phi plus alpha. So here the magnitude of induced EMF in both the coils is same because the number of turns are same, their size is also same, and placed in the same magnetic field, rotating at the same speed. But they are differ by the phase difference. See, the first coil A, it makes an angle omega t with reference, that is the first expression E1. And here it is, the coil B is making an angle alpha with respect to A. That means the angle of coil B from the reference is omega t plus alpha. This is omega t plus alpha. And therefore, the phase difference is alpha degree or radian. Now in this case, both the quantities are not achieving their maximum and minimum values at the same time, and therefore they are not in the same phase. Let us see their waveforms. See, this is the E1. Start from the origin because it is a reference. And now the second EMF, E2, achieves its maximum and minimum values earlier than the E1. So say this is, and having the same magnitude. This is E2. Sin omega t plus alpha. So here this phase difference is alpha. And here both the quantities are not achieving their maximum and minimum values at the same time. However, E2 achieves its maximum and minimum values earlier than E1. Voltage in coil B achieves its maximum and minimum values before the voltage in coil A. Therefore, the voltage E2, voltage in coil 2 or coil B leads voltage in A. Now the important point is, say this value is, say this is positive. At t equal to 0, here it is t equal to 0. At t equal to 0, the leading quantity has positive value. At t equal to 0, leading quantity has positive value. Now we will stop here. Today what we have learned in this video lecture, what is the phase? That is the nothing but the fraction of time period that is measured from the origin. It is either in terms of time or angular displacement theta. Then the in-phase quantities, here both the quantities achieve their maximum and minimum values at the same time. The quantities may be a similar or may be a voltage and current as shown. And we have also seen the phase difference. The phase difference, here the one quantity is leading the other and achieving its maximum value earlier than the previous one. The lead at t equal to 0, leading quantity has a positive value. So in this way we will stop here.